Hi class. So what I want to look at now are Fischer projections. What Fischer projections are is a way to take this, which is 2D, right? And in this one, we actually aren't showing any stereochemistry. Do you remember from organic where we do dash and wedge to show stereochemistry? Fischer projection does the same thing, except we can still draw it in a 2D structure. All right, so we're going to convert this amino acid into a Fischer projection. All right, so just briefly, let me remind you of the parts of an amino acid. We have our carboxylic acid, right, so here in red, our amino group here in blue, a hydrogen, and then this R is our side chain. So remember, that's the one that kind of gives the amino acids its identity, right? The R group is specific to each different amino acid. The rest of this is inherent in every amino acid. All right, so the way you want to start is we're always going to put the most oxidized carbon on top. All right, so that's going to be our carboxylic acid. So let's start by drawing a crosshair. So when you're doing amino acids, it's actually really nice because we can always just start with this kind of crosshair here. All right, so we're going to take the most oxidized one and put it on top. And so we said that's our carboxylic acid. So let's do that. All right. And just to remind you, it's most oxidized because we have an oxygen, 2 bonds, and another bond to an oxygen. So the most oxidized carbon is the carbon with the most carbon-oxygen bonds. Okay? Now, the other part of this is we're going to put this R group here at the bottom. Always goes on the bottom of this. So we're just going to put our R. All right, later we'll do an example that doesn't have the generic R. It actually has the actual atoms. All right, now let's say that we have this amino acid up here, and we wanted the L version of it. All right. So we don't actually have the stereochemistry shown here. So let's say we have this amino acid and we want to get the L. The nice thing about this is the L just tells us that the amine should be on the left. And if the amine is on the left, that means the only spot left for the hydrogen is on the right. Okay? All right, so let's try another one. So let's do the same thing here with this alanine. So we have alanine here on the left. So we're going to do this together. So if you want, why don't you pause the video and draw me the D version of this. All right. And then just start play again once you kind of figured it out. All right, so I'm assuming you've worked through it a little bit. Let's try it together. So the first thing you want to do is start by making your crosshairs. So we'll draw it like this. Now, just like before, the most oxidized carbon is this one here. All right, and we said that the most oxidized always goes on top. So we'll put that on top. Now, the other part of this is the CH3 group is our R group, right? Before, we just used the generic term R, but now we're actually working with a specific amino acid. So that means that CH3 should go on the bottom. I'm going to keep using that weird yellow color. Right, and it just mimics just like the R group above. All right, now, if we want a D, we want to put the highest priority, which in this case is the amine, on the right. And that means the hydrogen has to be on the left. All right, so what we're getting from this is that if it's L, the highest priority, so I'm going to write the highest priority, is going to be on the left. And if it's D, it's going to be on the right. And for these amino acids, what we're really comparing is the NH2 versus the hydrogen. And so the nitrogen will always be the highest priority. When we look at sugars in a little while, it'll be a little different because we'll have alcohols as well. But right now, for amino acids, we're just comparing the nitrogen versus the hydrogen. So the nitrogen will be our highest priority. So really, when we're looking at this, is the nitrogen on the left, then it's L. If the nitrogen's on the right, then it's D. And so if we come back over here, we can say this one, it's on the left. So this has to be my L amino acid. Here it's on the right. So it has to be my D. All right, I hope this helps you with understanding Fischer projections and also L and D.